Okay, Mr. Good afternoon. So, for that particular question that you want me to do, so the question says perform the BCD addition. Seven five eight and 643. So the first thing you are going to do, I haven't seen this question, is to write out your notations in binary number. What did I mean by notations in binary number? And when the lecturer was doing it in the class on Saturday, he did something of this nature: 8, 4, 2, and 1. So there's a rule that governs this. However, we are in adult class. I can't just begin to cram all those rules. But I know that you cannot do it is anything raised to power 2, sha. Sure you get. So for 8 now, write 0 in 8 places and then 1 in 8 places. So I'll have 0, 2, 3, 4, 5, 6, 7, 8. Then followed by 1. 1, 2, 3, 4, 5, 6, 7, 8. Sure you get now. Now this is 8, 8. Now for this 4 now, you're going to write 0 4 times until you finish. When you write 0 4 times, you write 1 4 times. You write 0 4 times, and you have 1 4 times. So this one will now have 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Then this one 2, 2. Then 1, 2, 1, 1, 1, 2, 1, 1. 1, 2, 1, 1, 1, 2. Oh, sorry. 2. Then 1, 1. Then the last one 0, 1, 0, 1. 0, 1. That's 1, 1. 0, 1. 0, 1. 0, 1. 0, 1. 0, 1. 0, 1. 0, 1. Now, if you look at this, is what you can even do yourself. This 0, the next one is 1, like that, like that, but don't let me go there. So for this one now, you cannot name them, but before you start, you always start with 0, because 0 is a number in binary. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there's supposed to be 16 number, so which means we are correct. Okay, now having done this, I wouldn't want to bore you with so many things, and because I don't want this video to be too lengthy. So what I will just do is that always neglect this. It's not that it's not useful, but in BDC notation, there's nothing like 10. Anything from 10 is invalid. So now for this particular question, I'm going to the next line now. I'll be referencing this. The reason why I wrote down this is because I want to be referencing it. So you get. Now they said 7, 5, 8. Oh, sorry. And 6, 4, 3. So what you do is that you write the value of 7 in binary notation. You write it out. So you split it into 3 places so that you can add. That's the addition. So how do we go about it? What is 7 on this table? 7 is 0, 1, 1, 1. So I'm taking 0, 1, 1, 1. I need to manage this space because I'm using Jota. So the next one is 5. So I'll go, what is 5? 0, 1, 0, 1. Don't know if you can see it. So so I will not put it together. I'll just do it separate. 0, 1, 0, 1. Then what is 8? I won't go there again. I am picking it. So I'll have 1, 0, 0, 0. Then the next one, 6 is under 7. So what is 6? I have 0, 1, 1, 0. What is 4? I have 0, 1, 0, 0. Then what is 3? I have 0, 0, 1, 1. So now this is where we start the addition. This is where we start the addition. So 0 plus 1 is 1. Uh, 1, 2, 3, 4. Okay, this 0 plus 1 is 1. Sorry, I mistake it. Then this 0 plus 0 is 0. Then this 1 plus 0 is 1. Then I go to the next one. 1 plus 0, 1. This plus this is 0. So this plus this is 2. But in binary, the only number we have is 2. I mean, is 1 and 0. Just like the lecturer said, it's either it is on or it is off. There's no other number in binary. So you get. So now that we now added these two and we have 2 now, what are we going to do? This is what we'll do. In binary, we have to divide. So we do this 2, 2. 2 divided by 2 is 1, remainder 0. This is this remainder that we use. I don't know if you are getting it. I'm sure you will get it. Just take your time. Now, don't forget, when I say 2 divided by 2 is 1, remainder 0, and I told you we are going to use the 0. So which means that my answer here will be what? 0. Then what will now happen to this one? This one, I will now bring it here. So I will now do 0 plus 0, 0 plus 1, 1. I hope that is clear. Then this one, you do the same thing. Is 0. Now, the same thing applicable here too. 1 plus 1 is 2. Then when you do 2 divided by 2, why did I get these 2? These things are in binary. They are in base 2. So you divide by the base, which is 2. Shake it. So where did I get this 2? This 2 is the answer here. This plus this is 2. That's the 2 here. This 2 that I used to divide it is the base. That's the binary base. That's 2 divided by 2 is 1, remainder 0. So here too, I'll have 0, remainder 1. Then I'll add that 1 here. So this 1 plus 1 will be 2, plus 1 will be 3. So if I do 3 here, 2 here, 2 divided by 3, 3 divided by 2 is 1, remainder 1. So I'll write the remainder, which is 1, 1 here. Then this 1, that is the answer, I'll put it here. Then I'll have 0 plus 0 plus 1. That will give us 1. Now this is where the twist is. Having looked at this, I told you, let me go here. I told you earlier on that you should neglect anything above 9. So you will now check your answer. Do we have anything that is above, that is more than this in that our answer? What am I saying in essence? These are the answers. Do we have anything that is greater than 9 here? If we want to check from our table that I draw at first. So starting from the first hand, 1011 is greater than, that is 11 on that table. If you check the table, that is 11. Check 0, 1011. So it's greater than 9. So what I would do is I would add 6. I will not just add 6. Which 6 am I adding? I'm adding the notation of 6 in binary form. That is 0110. Look at this also. Is this one more than 9? No, this is 9. This is 9. Gerege. So I will leave it. I will not touch it. Sure you get. But this one too is more than 9. Abi? Yeah, it's more than 9. This is 12. So I will also add 6. 0, 1, 1, 0. Sure you get. So you have to look at it one after the other before you can continue. You look at this. Does this one require 6? Does this one require 6? Anyone that requires 6, you add it. Sure you get. Now you put your sign here. Then you continue. 1 plus 0 is 1. This one just the way we did what is up here. So I have 0 remainder 1. So this one too will be 2. Abi? That's 0 remainder 1. Then this one too will be 2. That's 0 remainder 1. So I'll put it here. Don't worry. Just put the remainder. You know that this one now is now 5. Don't worry, I'll explain. Then bring this one down. 1, 0, 0, 1. Hmm? Now, do the same thing here. 0, 1, 1 plus 1, 2. When you do this, you have 0 remainder 1. Add that 1 to this one is 2. 0 remainder 1. Now, it is getting more difficult, but it is getting more easier. Now, what happened here is that the remainder here, there's nowhere to add it again after everything. So I have to bring it here. The same thing applicable to this. When I did this plus this 0, that's 2. Then I divide using this. I have 0 remainder 1. I add that 1 to this. 0 remainder 1. I add that 1 to this. 1 plus 1 is 2. 2 divided by 2 is 1 remainder 0. I put the 0 here. Then that 1, I have to bring it down here. So you get. Now, what is now the next step? This one is more than 5. This one is more than 5. So what you do is that from this part, always start your workings from here. Remove the excess, add it to the next figure. What am I saying in excess? Adding 1. So I will remove this one from here. This one that makes it 5. I will add it to this one. 1. This one, I will keep it separate. Don't worry, you will get there. So what I will do is this. This one will now turn to 1, 0, 0, 0. Because I've removed this one. Then add this one. This one will be 0. You understand why it's 0 now? Then add 1 to this. This one will be 1. Then this one will be 0. This one will be 1. Now, coming here, I put 0, 1, 0, 0. It is 4 already. Then this particular one, just keep it separate. Just keep it separate. Sure you get. Now, if you look at it now, this one is not more. This one is 1. This one is 10. And this one is 0, 0, 1, 0. 0, 0, 1, 0. And this one is 2. However, this one is more than 9. So we need to add 6 to this one again. Add 6. So you do this 0, 1, 1, 0. This one does not need anything again. So you can drop it down. 0, 1, 2, 3. Then you do your addition here. You have 0, 1 plus 1, 2. That's 0 remainder 1. 1 plus 1, 2. 0 remainder 1. Then 1 plus 1, 2. Then 0 remainder 1. So I'll put that one here. Then I bring this one down. 0, 1, 0, 0. This one, don't forget it. 1. Now, this one is now 5 again. So you know the next thing to do now. So you add 1. So I do this. 1 to the next one. Oh. So I will do this 1 here. Then I'll have this one will still remain the same. This one will not be 3, 4. This one will not be there again because this is it here. So this one here will be 1. This one here will be 1. This one here will be 0, 0. Now this one, if you now look at, I brought it down. If you now look at this, is any one of it above 9? None of them is above 9. So then this one, what are we going to do to it? Just add 3 0 to the front. That will give us 1. This one itself is 1. 1, 0, 0, 1, 1 on the table. What does 0, 0, 1, 1? It was 0, 0, 1, 1. That's 3. 3. Then this one is 0. You can go and check the table. And this one is 1. So that is the answer. So we have 1304. So if you do it the normal way also, 643. This one will give us 11. This one is 10. That is 0. Remember one. This is 13, 14. It's supposed to be 14. I think I made a mistake. Let me check for me. I've made a mistake. Okay, I made a mistake. I said 1 plus 0. I put 0 here instead of 1. 1 plus 0 is 1, not 0. So then every other one will be right. So this one will be 1. Okay. So this one will be 1. So if this one is 1 here, then this one will be 0, 0, 1. So this one will give us 4. So that's my answer. Yeah, I hope you understand. Well, I can share more light when we meet, yeah.